Hi boys and girls, it's Mrs. Twisdell. This is chapter 12.7, the effects of outliers. Your objective for today is I can determine the effects of outliers on measures of center. Now this word measures of center, that's like the mean, median, mode, and range. So think about why we find the measure of center in a data set. We really find that measure of center so we can say what's the middle, where's the average, where are most people scoring or falling, or what's the average price, whatever our data is. But every once in a while, you're going to have what's called an outlier. An outlier is a value of your data set that is much lower or higher than everything else and throws off your mean, median, and mode. So it's the piece of data that looks different. Everything else is kind of the same, and it's just totally out there. It's called an outlier. If you look at this comic, so everything else falls on this beautiful curve, all the other dots are on the line, and then you've got this outlier, okay? And this guy's saying, outlier, which is kind of funny. And look at all of these temperatures. You've got 71, 70, 73, 70, 70, 69, 70, 72, 71, 300, 71, 69. So that is an outlier with all the rest of your data being around 70, and this one is so far above. It's an outlier. Okay, so sometimes these outliers throw off our mean, median, and mode, and so oftentimes we can include or exclude the outlier so it doesn't throw off. So let's go ahead and look at this first problem. This table gives the number of days that the 24 members of the Garfield Middle School volleyball team were absent from school last year. So we're looking at the volleyball team and how often they were absent. Looks like there was 4 days absent, 6 days, 7, 4, 5, 5, 3, 6. All these numbers are pretty similar. 6, 7, 3, 5, 8, 16, 5, 4, 5, 6, 5, 7, 6, 4, 5, and 4. Does your data set contain any outliers? Does it contain any numbers that are way too small or way too big? Okay, let's go ahead and find out. You might already say it, Mrs. Twisdell, I get it. I know what I'm doing. But if not, let's go ahead and plot the data on the number line. So, they gave us the number line. I'm making a dot plot. You guys remember how to do this. I'm just going to put a dot for each number. Okay. I'm going to pause the video so I can quickly fill in my dot plot. So just give me a second and I'll fill it in. Alright, so I went ahead and filled in this dot plot. And as you notice, it's not very accurate looking. It's kind of sloppy. But that's because I couldn't draw dots that small. But the step 2 is you're going to find any values that are much greater or much less than the other values. So most of the data values are between 3 and 8. Oops, let's see. Sorry, 3 and 8. The value 16, do you see that one? Is so much greater than the rest, so 16 is our outlier. Okay, so do you notice how everything else kind of falls in this category right here? And 16 is like clear over here. It's that red apple among the green apples. It's just so different. It's so out there that it is an outlier. So I want you to try this one. You're going to just try the first part and then I'll help you with the next part. But you're looking at the prices of the X40 laser printer, so you guys know what a printer is, at 5 different stores. One store it's $99, one store it's $68, one store it's $98, one store it's $105, and one store it's $90. Now, the mean price is $92, and the median price is $98. Identify the outlier and describe how the mean and median are affected by it. So, go ahead and first of all identify which one is the outlier. I hope you said that the outlier is $68. That one is way cheaper than the rest. And it's throwing off some of what we're seeing here. So, identify the outlier. Okay, which we did, and now we're going to find the mean without the outlier. So I'm going to take out this 68 right here. I'm going to find the mean with just these other numbers. So 99 plus 98 plus 105 plus 90, and then I'm going to divide it by 4. And I plug this in the calculator, it gives me 392. Divided by 4 gives me 98. So 98 is the mean price without the outlier, but with the outlier it was 92. So we're comparing that to 92, okay? That's with the outlier. Oh, that was a weird looking 9. But without the outlier it's 98, which is probably a closer estimate. And then our median, if I put these in order without the outlier, let's see, our smallest would be 90, 98, oh yeah, 98, 99, and 105. Remember, median's the middle, so we take off these two. 98, oh, that one's supposed to say 99, so it'd be 98 and a half. So it'd be in the middle of those two. Okay, $98.50, which is similar to $98. So how does the mean and the median, are they affected by it? Yes. The mean was a lot lower with the outlier. Okay. When we included that outlier in our data set, it dropped our mean to $92 when it really should have been about 98. But because that 68 was so low, it pulled our whole average down with the outlier. So again, I just want you to notice that when we have those outliers, it can really affect either the mean, the median, or the mode, because it changes our average and it doesn't give us a real clear indicator of what's the middle. Alright, so now I want you to find this one on your own. By how much does the median of the data set 2, 3, 5, 5, and 10 change if you remove the outlier? So first you need to decide what number is the outlier, find the median with the outlier, and then find the median without, and then decide the answer. Go ahead and pause and try. Alright, so when I solved this with the outlier, it looks like our two middle numbers were 5 and 5, which if you average those out, it gives you the answer of 5. When I took the outlier 10 out of the equation, out of the problem, my median was still 5, so it did not decrease by 2, it did not decrease by 1, it is unchanged, and it did not increase by 1. Okay, so sometimes the outliers affect the answer, sometimes they do not. Outliers are just kind of a weird thing that you should know about. That's all of our lesson for today. I hope you guys understand outliers and how it affects those centers, measures of center. Have a good day.